I'm Dr. D. Narayanasamy. I'm going to give a lecture on wave interactions. Different waves, different result. What is meant by waves? We go for longitudinal wave. First of all, we must know what is meant by longitudinal wave. The image of the animated image shows the real longitudinal wave format, that is from down to up or up to down. That is the longitudinal wave format. Wave particle vibrate back and forth along the path that the wave travels. That is the compression wave. Another name of the wave is compression wave. What is meant by compression? The animated image gives the compression. The close together from one to another, it is very close part of the wave, that is known as compression. What is meant by rarefaction? The spread out part of the wave is known as rarefaction. Spread out part is known as rarefaction. Then transverse wave. What is meant by transverse wave? This picture shows the transverse wave format. Wave particle vibrate in up and down motion is known as transverse wave. First, crest. What is meant by crest? Topmost is known as crest. Highest part of wave is known as crest. What is meant by trough? The lowest part is known as trough. The low point of the wave. That is the animated picture gives information about the transverse wave, crest and troughs. The up and down the vibration gives the information. What is meant by amplitude? Amplitude is the main part for the sound engineering. The maximum distance the particle will vibrate from their position, from original position to higher position. And next, frequency. Frequency means the number of waves produced in the given time is known as frequency. The animated picture gives the information about the maximum pitch level and minimum pitch level. The frequency is equal to waves per time. That gives a wave transfer energy without transferring matter. Wave velocity. Velocity is displacement with respect to time. What is meant by wave velocity? Is the speed with which a wave crest passes by a particular point in a space. It is measured in the meter per second. Wave velocity equal to multiplication of frequency and wavelength. The speed of the sound in air 20 degrees Celsius. The speed is 343 meter per second. For example, diamond 12,000 meter per second, glass 5,640 meter per second. That is the speed of sound waves in a different medium. So what is the properties of sound? What are the properties of sound? Pitch. Pitch is the main role, description of how high and low. Now, so for example, old age people sound is very low as compared to female voice. So pitch is the description of how high or low the sound seems to a person. Next, loudness. Loudness, how loud or soft a sound is perceived by to be human. Loudness of sound in decibel is the sound that is average in home, 40 to 50 loudness in decibel. Hearing does not damage. Loud in music, 90 to 100 after long exposure. Rock concert, 115 to 120, it is very progressive. For jet engine of aeroplane, 120 to 170, it is pain for the normal human hair. Then ultrasound. Ultrasound is the main part in the sound engineering. Sound waves, the frequency above the normal human range of the hearing is known as ultrasound. Ultrasound in the range from 20 to 100 kHz is the frequency range of the ultrasound. Infrasound is the sound with frequency below the normal human range of the human hearing is known as infrasound. Sound in the range of 20 to 200 Hz range. This picture gives the information of the inner organ body of the human by using ultrasound system. Interference. Different wave, each and every color gives the information of different waves with a different amplitude. The result of two or more sound wave overlapping, that is the interference of the sound waves. And different sound that you hear include A is the noise, A is the noise of the sound, the pitch and the amplitude is not in a uniform state, and P is the pure tone, that is the pure tone, and and see the musical notes. Comparatively, both three sounds are differ from one another. From the comparing of length of the frequency, first one is F1 is the fundamental frequency, S and the next one is F2 first overtone, F3 is the second overtone. For example, from the representation of these three diagrams, F1 is the first fundamental overtone, F2 is the second, and the third one is the overlapping. The L equal to lambda is the frequency, lambda is the wavelength by 4, L equal to 3 of lambda by 4, L equal to 5 of lambda by 4. The standing sine wave patterns of air vibrating in the closed tube. Note that the important point is node at the closed end of each and every diagram, and the antnode at the open end. Only odd multiples of the fundamentals are therefore possible. Standing waves in this open tube have an antnode at the open end where air is free to vibrate. These are the pictures of the node and antnode sine waves. Doppler effect. For sound engineering, Doppler effect is the main role is the apparent change in the frequency of sound caused by the motion of either the listener or the source of the sound, that is known as Doppler effect. And the picture gives the information about the Doppler effect. At the front side, long wavelength, low frequency. At the back side of the vehicle, small wavelength, high frequency. These are the simplest format explanation for the Doppler effect for the moving sound source. Sound from moving source. A moving source of sound or moving observer experience an apparent shift of frequency called the Doppler effect. If the source is moving as faster than the speed of sound, the sound will pile up into a shock wave called a sonic boom. A sonic boom sound very much like the pressure wave from explosion, bomb explosion. This gives a picture of the supersonic flight, and the second one is the supersonic flight imagination, the diagram. Resonance. Resonance for the sound wave, the frequency of sound wave exactly matches. This is the bubbles of gives the information of the water waves vibrated from top to bottom. Tsunami warning. On December 26, they were playing in the sea when the Tilly suddenly found the water was bubbling like on top of a beer. She immediately realized tsunami was coming because the scene reminded her a geography lesson about the Hawaii's 1946 tsunami. Right away, Till told her parents, sisters and other tourists to escape quickly. But at the first they were in a half belief. However, seeing Tilly's serious and firm expression, people started to be convinced of the seriousness of the thing and instantly left the beach. At the last hour, 100 tourists were ended up in safety with no death. Thank you.